Howdy. Welcome to the short course for Introduction to Machine Learning Basics again. In the past few sessions, we have gone over several important supervised machine learning algorithms from linear models to many nonlinear, in particular, non-parametric instance-based supervised machine learning algorithms. And for the next two sessions, actually, we are going to introduce some basic information about the deep neural networks. And in fact, deep neural networks have been probably the most popular machine learning models in recent years since at the beginning of this century. The reason is that the empirical performance of deep learning models indeed is better than the traditional machine learning algorithms. And in fact, before deep learning, two machine learning methods we have already introduced: support vector machines with kernel tricks and random forest. Those two machine learning models are actually top performing supervised learning algorithms. And you can see that both of them indeed are trying to capture more complex functional mapping from the input features to output labels compared to the linear models. Right. So one of questions for machine learning researchers had is that whether a computer can emulate a human brain to do predictions, right? So there are lots of actually neuroscience research studying human brain and studying neurons, and there is one interesting research in the last century, 50s. People kind of use a simple mathematical model to kind of approximate or simulate brain neuron activation, and which is essentially the perceptron model, right? So actually, perceptron itself is, in fact, a very simple machine learning model. But similar as human brains, you have many neurons interconnected to do the memory, do the reasoning. So people come up with the idea whether we can combine all the perceptrons to help you to derive better reasoning or prediction performance. And this type of methods, by combining a huge number of potential weak models or weak learners to derive strong prediction, is known as ensemble methods. And one of very important ensemble methods is the boosting algorithm. And one of the boosting algorithms is known as AdaBoost. So AdaBoost actually, as a machine learning algorithm, including its theoretical analysis, has won many awards in machine learning community. The reason is that not only the AdaBoost idea of combining multiple weak learners, empirically it can derive really good prediction, but also theoretically, there is a very rigorous proof saying that the way doing boosting sequentially, combining many weak learners, indeed can avoid overfitting. Right? So compared to random forest, actually the theoretical analysis of AdaBoost algorithm is much stronger. right? So that's why AdaBoost has been receiving quite a few machine learning awards. And then boosting is just a one way doing ensemble methods by combining perceptrons or the other weak learners. Then another direction of machine learning research is to derive so-called artificial neural networks to emulate human brains. So artificial neural networks is essentially trying to have certain ways of combining a huge number of perceptrons, so that also empirically you are trying to achieve very good prediction performance, right? So, and then on top of artificial neural networks, then people try to do better or try to approximate the human brain better by taking advantage of a potential local dependency of the perception fields, in a sense, right? So basically trying to taking advantage the potential local dependency relationship, they are trying to further improve the way how you are going to combine the information and derive better prediction performances. So that's more recent, the past decade, deep neural network research is trying to do. Right? So now for this first section, actually we are going to basically quickly go over the basic introduction of perceptron model, and then based on the perceptron model, we talk about the ensemble learning, focusing on the AdaBoost boosting algorithm, and then we will briefly introduce the artificial neural network model. And as in the past, we will briefly introduce, once you have the artificial neural network model, how you are going to actually derive the model parameters, so that when a new data point comes in, you can do the reliable prediction or accurate prediction. So this is what we are going to do for today's session. So here it's actually same importing Python code segment. So basically you are going to use scikit-learn again, use multiple built-in machine learning algorithms. One of the important thing we are going to test is this AdaBoost algorithm. AdaBoost algorithm actually can take different forms of weak learners, including perceptrons, including decision trees, etc.